Hi everyone. In this video, I'm going to look at section 3.3 of the textbook. It's going to be on the factor theorem, and I'm just going to do one example, but it's a long example. So the factor theorem tells us whether or not the divisor is a factor of the dividend. If there is no remainder, or when the remainder is equal to 0, then the divisor is a factor. So, you know how we were looking at x minus a, we were looking at whether or not something is a factor. You take that a value and you plug it into your polynomial. If you get it equal to 0, that's when it is a factor. So the factor theorem states that x minus a is a factor of p of x if and only if p of a is equal to 0. Okay, so let's look at this example here. Number 1, determine whether or not x plus 2 is a factor of f of x when f of x equals x cubed minus 6x minus 4. All right, because we have x plus 2, what we're going to do is we're going to use x equal to minus 2. And then we're going to take it and plug it into this polynomial here to determine whether or not it is a factor. Now we want it to equal 0. So let's do that. So we want to actually do the calculation of f of negative 2. So wherever you see an x, plug in a negative 2. And in this case, we see that the result is, in fact, 0. So we can say, yes, it is a factor. Is a factor. I probably should have given myself a little more room to write that down. Okay, now let's look at this question here where it says completely factor p of x, x cubed minus 7x plus 6. Just as a side note, just notice that the x squared term is missing. Okay, so you're aware of what you're looking at. And in order to start us off, what we're going to do is we're going to use the remainder theorem to decide, well, if the remainder is 0, then it means that it is a factor. So let's look at let's look at our constant here, and we're going to use the factors of positive 6. So the factors of positive 6 are plus minus 1, plus minus 2, plus minus 3, plus minus 6, and these are the numbers that we're going to be plugging in order to determine whether or not certain numbers are factors. Nothing else is possible to actually plug in and to work. So let's start with the factor x minus 1. So we're going to use x equals 1, and in p of x, we're going to plug in the 1 wherever you see the x, and then we are going to see the result is 0 for this one. Since it's 0, x minus 1 is a factor. All right, so next we're going to check x plus 1. We're going to use x equals negative 1, plugging that into our p of x, and we're going to get here that p of negative 1 is equal to 12. So that tells us x plus 1 is not a factor. All right. Now next we can try x minus 2, and then I'm going to try x plus 2. So for that, I'm going to use x equals negative 2. So why don't you give these two a try, give the rest a try, and then I will come back with the answers and see if yours match mine. Okay, so now that we're back, and we're going to look at the last one I left you with was x minus 2 and x plus 2. So the reveal here for x minus 2, when we used x equals 2 to plug it into our p of x, we ended up getting that it does equal 0. So yes, it is a factor. Okay, and x plus 2, when we used x minus 2, when we used x equals -2 to substitute in here, we ended up getting that it was equal to 12. And so that means it's not 0. So it's not a factor, and we're going to move on to the next one. Let's see if x minus 3 is a factor. Well, we used plus 3 to plug in, and we end up getting that it's equal to 12. And so that tells us it's not a factor. And to determine whether x plus 3 is a factor, we use -3 to plug into our p of x, and we actually end up getting it equal to 0. So that is a factor. So then you notice that this is a cubic at the beginning. Here, this is a cubic. So at most it can have 3 factors. So I'm not even going to bother figuring out this plus minus 6 because I've already found my 3. I found this one right here, and this one here, and that one there. So then I could have a statement at the end, and it could look like, since P of 1 is equal to 0, P of 2 was equal to 0, and P of -3 was equal to 0. That means that P of x could also be written this way: x minus 1, x minus 2, and x plus 3. So those are all factors of my original question that was given, which was x cubed minus 7x plus 6. Okay, so we could also say that x minus 1, x minus 2, and x plus 3 are factors of p of x, which is x cubed minus 7x plus 6. All right, so just to clarify, just to reiterate what I said earlier, what we want to do is we want to use the constant, and we want to take the factors of the constant in the polynomial to decide what factors, what numbers we're going to use to plug in to see whether or not there is a remainder or there is no remainder, which means that it's a factor. So in this case, it was plus minus 1, plus minus 2, plus minus 3, plus minus 6.